Hello, have a nice day. If you want to go around the Earth 7 times in a second, go to the Moon in 3 seconds, and come back in a few hours, and go to the edge of the solar system, and come back to us. If you also want to go on such amazing journeys, you have to travel at the speed of light. Let's talk a little bit, and say that you are interested in it today. Do you really think that we can practically reach the speed of light? Can we go faster than that? What will happen if we reach that speed? All these things are discussed in this video today. We invite you to reserve this special video. We invite you to stay with us throughout the amazing universe. We invite you to stay with your beloved universe until the last few seconds of this special video. Let's start like this. If someone can achieve a fractional speed like the speed of light, that person can reach Mars in about 10 minutes. This is something that is approximately 150,000 kilometers per second. But before this happens, the person will have to face several strange experiences. In fact, the only problem is that a group of scientists from the same technology institute have produced a separate video game so that someone can experience it at a speed that is close to the speed of light. In this game, you start at a standstill and gradually increase the speed and see how the images appear as you approach the speed of light. In this game, instead of making the person who participated in the competition age, the light travels slower compared to that speed. Then we can actually see the way we see things around us. As we reach a speed of 0.2 of a second, the way we see things around us changes. You want to know that what is ahead turns a little brighter. The purple color of the wedding ring increases. If you look at it from behind, those things appear dark red. This is because of a scientific phenomenon called the Doppler effect. In short, things like stars that are moving away from us at such a speed appear red, and things like the Andromeda galaxy appear red. Why do we see things like the Andromeda galaxy moving towards us in red? When you reach a speed of 0.5 of the speed of light, this is the Doppler effect. It creates infrared and ultraviolet images right in front of your eyes. When you turn your face from left to right, you can see these colors changing in an instant. But wait a minute, this is a game. This is really not the case. But life is about 10 million atoms in a cubic meter of space between the Earth and the Moon. If you were to go through this at such a huge speed as I said, all of these would be like bullets for you. Just imagine. That journey takes place in a specially equipped spacecraft, which reaches a speed of 0.2 of the speed of light. We see not only the difference in appearance mentioned earlier, but also the collision of atoms in our spacecraft, which causes small particles to collide, and then a slightly larger particle to form, creating a radioactive environment worse than Chernobyl. Then, at about half the speed of light, these conditions would be even worse. According to science, at this speed, a particle of dust would release as much energy as an atomic bomb. So, trying something like this between Earth and Mars is just a fantasy. As you can see, in the far corner of the solar system, there are about 1,000 atoms per meter. In such an environment, even if we go at this speed, the atoms will have an unfortunate fate. The probability is relatively low. If we make our plane flat and build a shell that can withstand the explosions caused by atoms, we have a small chance of being more than half as fast as light. The challenges ahead are even more severe. We are about to go to our video game, and when we reach 80% of the speed of light, we have a very bright Doppler shift in light, which makes it difficult for us to see ahead. And if we look back, everything is completely dark in front of you. This is because normal light has difficulty traveling with you, so those light shifts become invisible radio waves. To experience the other effects and experiences of reaching the speed of light, we need to remove the application that displays this Doppler effect and play the game. When we do this, distant objects become even further away. The space we can see becomes flatter, and we are moving forward at an incredible speed. With Einstein's theory of relativity, with Einstein's scientific arguments, when we approach the speed of light, everything in front of us appears to be, in short, the Earth. To such a person, should appear like a flat disk. According to Einstein's theory of relativity, as a person approaches the speed of light, space-time should appear to slow down. According to this, photons emitted from different parts of the objects in front of you reach your eye after a significant delay, and the path of vision becomes flat. This is why this little thing, according to Einstein's theory of relativity, or according to the equation, when we approach the speed of light, our mass also increases. The reason is that according to those equations, the energy we spend to gain momentum is converted into mass. According to the calculations, something gains a speed of 9 times the speed of light. When the mass doubles, the energy that is added to it increases the mass. To put it simply, if an object or a person has mass, it is practically impossible to reach it. Some things have been reported in the practical world that light has traveled faster than it. How can that be? Look at some places. It is true that in some laboratory experiments, it has been reported from time to time that some things with mass have exceeded the speed of light. But all those facts are just optical illusions when further tests are done. Let's assume for a moment that we do not have mass. Now that we have approached the speed of light, what do we have? We see it in a completely dark environment. The reason for this is that at the speed of light, the effect of time dilation is infinite. If we understand this, anyone who reaches the speed of light gets stuck in a moment. Is there really no way to go beyond this? We also feel the same way. To be honest, even today, scientists are trying to exceed the speed of light in some way. Let's say that this was successful. Now there is a small problem. What happens to time in the meantime? While the physical theory of how to travel to a star 4.2 light-years away from Earth in 4 days is being developed, the scientist Serge Krosniko has presented a method that can reach a speed of 100 times the speed of light in the space-time space. The Mexican scientist Miguel said that in the same way, he has successfully shown how to achieve a speed of 100 times the speed of light without breaking the equations of the same field. Both of these methods, simply put, both of these methods have been proven physically and cannot be developed practically. The German Erich Lenz presented a method that circumvents this problem by using ordinary fuel, which is 100 times the fuel of the planet Jupiter, so let's not talk about it anymore. Because we cannot say right now that a method that can be practically implemented in our future, with the advancement of science and technology, will not come. Scientists have not given up on thinking optimistically. The University of Adelaide in Australia has already started that amazing work. Some research has shown that it has shown signs of success. Let's assume for now that we can travel at the speed of light. This story will make you understand. Then what happens next? We enter a wonderful place where time flies. Think about this. We have reached a speed of 1.2 times the speed of light. There is a problem. Now we have to increase the speed back in time. We are traveling in space. Now, after talking about this old thing, one might think, is this time travel? No. It's not like you are traveling back in time. This is when you suddenly become slower than the speed of light. In that attempt, we actually experience a speed of about 8 decimal times the speed of light. It's like adding a negative sign to a mathematical equation. Every time you try to do something like this, it's like hitting your head against a wall. This sudden change in speed creates a huge energy difference. No one can stop you from being crushed and evaporated like a lot of jelly. It can also happen. Finally, if we can't travel faster than the speed of light, at least can't we send a message at that speed? Again, if we take it from a physical point of view, there is nothing that can't be achieved. In 2022, the Nobel Prize in Physics was awarded for this research. If we want to make it a reality, we need to go a long way in science. Also, it takes more than the speed of light to transmit messages and destroy the universe. It can be concluded that it would be beneficial for everyone to do something that is happening and being done from here at the speed of the world.